Alright guys, so still the same chapter, but we're going to take a little bit of a detour. So we're talking about square roots, cube roots, fourth roots, all those roots right here, but we're going to do a little bit of an exponent review. And that's because throughout all that we did have to talk about exponents, so we want to make sure we remember all of those good exponent rules. So we're going to add that on 87 and 88. Okay, so I have all these things attached for you aside from the divider, but this one is something that you're gonna cut in half, and like if you want to cut out each little door you can do that. We have our poof book right here, which we might not fill all of that out, but we'll see. And then we have this one right here, which is actually where I'm gonna start. So this is kind of the flow that I follow when I'm simplifying things with lots of exponents. So for instance, if I have a problem, I'm going to kind of use the same problem going all the way down here to sort of show you how this works. So I can fit it. Should maybe wrote a little smaller. Okay, so if I have a problem like this, if there are any parentheses with an exponent outside of them, then you need to distribute that exponent by multiplying it to each exponent inside, which every single number has an exponent. If I don't see it, that exponent is 1. So like here I distribute it as well, and I'm going to distribute to each of these, which both have a 1. There are no parentheses here, but I'm going to distribute down here. And so when I rewrite this one, we're going to have on the first numerator 4 to the third, which I can do that in a minute, and then we'll have x to the 6th because we distribute by multiplying. Still on the top over here I have x to the 4th and then y. On bottom we're going to be 2 to the 3rd, x to the 3rd, and I distribute over here as well, x squared, y squared. Now you learned all these rules before in Algebra 1, so there's lots of different ways you can go after this, but this is again like the flow that I like to follow. Now if there are no exponents outside of parentheses, you skip that step. So kind of like I did here, didn't do it. Okay, the next thing I like to do is if I have multiple fractions, then I go across the top and across the bottom, and I multiply by adding the exponent of like numbers or letters. So like across the top here I have the number 4, but there are no other 4s, so the 4 to the 3rd is just going to stay, but I'm going to do it like 4 times 4 times 4 is 64. However, across the top I have an x here and an x there. So since they're the same, I add their exponents for x to the 10th, which we've been doing this all along. I just didn't explicitly state it. Now we just maybe need to really review and know it. Now there are no other y's across the top, so y is going to stay to the 1st. And then I go across the bottom, do the same thing. Now there's 2, but there are no other 2's, so that 2 to the 3rd is going to stay 2 to the 3rd, but I can do 2 times 2 times 2, and it's 8, so I might as well. Now there are multiple x's again, so we're going to add those up, so x to the 5th, but there are no other y's, and so we're going to stay y to the 2nd. If there weren't like numbers or letters, then you just skip that step. So now we're all just one fraction, which is super nice. Next, we want to divide top to bottom by thinking about how far apart exponents of like numbers are. And then keep that term wherever the larger one is, either top or bottom. So this is kind of confusing because I think normally when you think division with exponents, we subtracted. And we are doing that when we think how far apart. But this way it works a little nicer because then I don't have to deal with negatives. So as far as numbers go, I'm just going to divide. And the same thing kind of happens here. 64 divided by 8 is 8. And the 8 is going to stay on top because 64 is larger. And then you have a 1 on bottom that you don't need. Now because the x's are the same, we're going to think about how far apart their exponents are. So how far apart are 10 and 5? And they are 5 apart, and the 10 is larger, so it's going to stay on the top. So x to the 5th goes here. It's like you have 10 x's on top, 5 on bottom, and so the 5 cancel out, but you're still left with 5 on top. Now the y's are the same, and there's 1 on top, 2 on bottom, and so 1 and 2 are 1 apart, but this y on the bottom is larger, so your y to the 1st which you can put the 1 there or not, is going to stay on the bottom. If there aren't like numbers or letters, then you can skip that step. Okay, last thing I do is after all that, if there are any negative exponents, then I have to move them, which I don't have here, but I'll show you what I mean in a minute. Top to bottom or bottom to top. If you have any 0 exponents, then you replace that entire number with a 1. So for instance, if I had something crazy like 4x to the negative third over y to the negative second, z to the 0, I treat each number on its own. Now 4 is to the first power, which is positive, so it stays in the numerator. But the x has a negative power and there are no other x's, so this guy's got to move to the bottom to become positive because we don't want negative exponents. Next number I see is y to the negative second. Can't have negative exponents. It's on the bottom now, so it's going to move to the top so that it can become positive. And then anything to the 0 power is just completely replaced with a 1. So this is 1, and it stays on the bottom, and anything times 1 is that thing, so you kind of don't need to put that 1 there. And so this would be your final answer, 4y squared over x to the third. Okay, so that's kind of a big example. Now, all of these little rules right here are just those individual rules. So if I'm multiplying bases that are the same, we add their exponents. So for example, if I had 4 to the half power times 4 to the 3/4 power, because your 4's are the same, you can write it 4 to some power, but I need to add those, and for me it's not super easy to add fractions in my head, so I'm going to do a little side math and do half plus 3/4, and I need to have a common denominator, so I'm going to times this guy by 2 over 2, so it'll be 2 over 4, which is still half. When I add it to the 3/4, I become 5/4. Okay. If I have a number to a power with parentheses and then another power outside, that's when we multiply by distributing in. Okay, so you might have something like x to the 1/3 power squared. And so I would distribute that 2 in, and 2 times 1/3, if I need to write that out, it's really 2 over 1. And so this becomes x to the 2/3 power. Okay, another rule we have is the distributing rule, which is basically like the power rule, where if you have a power outside, it just goes to both the numbers inside. And so, for instance, if I had 2x to the third to the 1/4 power, getting some crazy fractions up in here, that 1/4 would have to go to 2's power, which is 1, and to the 3rd power right here, and so it'd be 2 to the 1/4 power, because 1 times 1/4 is 1/4, and then x to the 3/4 power, because we do the 3 times the 1, and then the 1 under the 3 times the 4. Okay, just getting some familiarity with fractions. We have that negative rule that I was talking about right at the end there. If I have any number to the negative power, I have to move it. So if it was in the numerator, because technically that's over 1, then I just move it to the bottom. The thing we want to be careful about though is that we don't move everything. So if I had something like x to the negative third over y squared, we need to treat everything individually. So the x has a negative power. It's currently in the numerator, so it's got to go to the bottom. The y, however, has a positive power, so it's going to stay exactly where it is. And I need something on the top of my fraction, so I can always have a placeholder of 1 up there if everything kind of moves to the bottom. Okay. Next we have division, which with division you are subtracting, but like I said, I like to think about how far apart. But I mean, truly what you're doing there is like if I have x to the 2/5 power divided by x to the 1/5 power, I think about how far apart those are, and luckily since they have the same denominator, that's kind of easy to subtract, and that would be 1/5. And then the numerator is larger because 2/5 is bigger than 1/5, And so the 1/5 would stay at the top, and I wouldn't need a denominator anymore. Again, really I'm just doing 2/5 minus 1/5. And since it's positive, it stays put in the numerator. It doesn't move to the bottom. And then last but not least, if we have division with big parentheses, then I might have to distribute as well. So if I had something like 2x over y to the 1/3 all to the 6th power, that would become 2 to the 6th power, which I could do like 2 times 2 times 2 times 2 times 2 times 2, which is big. X to the 6th power over y to the, then 6 times 1/3, I'm going to do a little side math on that because I think we can cross cancel a little bit, and it's just going to be y to the 2nd. Now all these are different, so I can't divide top to bottom, and so I'd probably leave it like this. Maybe I change that 2 to the 6th to 32 or whatever it is. Okay, so try some examples in here together. Simplifying expressions with rational exponents. This is just, we're simplifying math that have exponents, so all the stuff that we've been talking about. However, my exponents now are gonna be fractional. And so I'll know that it's simplified when there is only one of each letter, no negative exponents, no zero exponents, and numbers are reduced. So like if I'm dividing, I want to divide out numbers that I can divide, or if I'm multiplying, I want to multiply and make bigger if I can. So the front page in here is really just more of the examples that we just did. So I think I can probably skip that. But we'll go to example 1. Okay, so example 1, part A. I have to have the same number, and I don't here, so I can't combine. So this is already simplified. You can only do it when your numbers or letters are the same. So that boy's already simplified. So working our way down here. Now I can't combine inside because the 4 and 5 are different, but I do have parentheses with an exponent outside, so we're going to distribute that into both. And so I'm going to have 4 to the 2/3 power times 3, which we might have to do a little side math, times 5 to the 3/4 power times 3. Now the 3 is really over 1, and it's always nice to be in fraction land if you're in fraction land. So for the 4, because I have a 3 on top and bottom, they will cancel out, and you're just going to be 4 to the 2nd. Now over here though, you have 3's both on top, so you're not going to cancel anything. This is going to be 5 to the 9/4 power, which doesn't reduce or anything. The only thing I can really do more here, because I don't know how to do 5 to the 9/4 power, don't know what it is, but I can do 4 squared, that's 16. So I might just call this 16 times 5 to the 9/4 power. And like that's as far as I'm going to go, because again, I don't know how to do that. So since I can't do the exponent, I can't multiply it to the 16. Okay, so for example C right here, we're dividing. The bases are the same, like we have the same number here. So when we're dividing, we subtract, and maybe it's good to do a little side math. So we'll do 2/3 minus 1/3. And since they have the same denominator, we can just subtract the numerators. So 1/3. So our base stays the same. We're going to be 4 to the 1/3 power. It's going to be in the numerator because it was positive, and I don't know what 4 to the 1/3 power is, so I'm just going to leave it. Oop, already simplified. Okay, here we're going to distribute, so we're going to do that little side math, like 3 over 2 times 2 over 1. So I can cancel that, it's all like 3 to that power. And so that's going to end up being just 3 to the 3rd, which I know is 27. So like we want to go as far as we can go. Now if that was like 3 to the 7th power, you probably don't need to do it. But like 3 to the 3rd, 3 to the 4th, maybe even 3 to the 5th, I feel like is okay to do. Okay, so here we're dividing. I don't know, do 64 and 50, well, they definitely got 2 in common. Like, I can divide a 2 out of that. Let's do that. So 27 over 32. They got more stuff in common? I don't think so. So I would just reduce the fraction inside because I noticed they were both even. And if you can make your number smaller, like, why not? But then I got to distribute the exponent to both the numbers in here because we got those parentheses. And so we're going to be 27 to the 1/3 power over 32 to the 1/3 power. And like, these numbers aren't the same, so I can't subtract the exponents, and I don't know what 27 to the 1/3 power is or 32 to the 1/3 power, and so I'm done. Okay, last but not least, we got 6 to the 2/3 power to the 3/4 power. So when we have that parentheses like that, we're going to distribute by multiplying. And so we're 6 to the 2/3 times 3/4 power, which is super nice because like the 3's can divide out. And I can cross cancel this way because 2 goes into itself once and into 4 2 times. And so this becomes 6, and then in the numerator I got a 1. In my denominator I got a 2, so 6 to the 1/2 power. And I don't know what 6 to the 1/2 power is, so I'm just going to leave it. Alrighty, example 2. So I'm going to do all these examples for you because I'm actually going to have you guys try a worksheet on this one instead. So, you know, the only thing you have to submit to me is your homework. Whatever notes you take, those are up to you. Okay, so let's get some x's involved, right? So these are the same, and since we're multiplying, we're going to add. So we're really adding 1/3 plus 4/3, which is nice because they have the same denominator. So 5/3 is going to be my exponent, so x to the 5/3 power. Okay, here we're dividing, and they are the same because x's are the same, and when we divide, we subtract. Now here's what I'm talking about. So if I subtract, I get 2/3 minus 5/3. Now again, it's super nice because denominators are the same, but when I subtract, I get a negative number, which if you just ignore that and like take the absolute value of it, like 3 over 3 is 1, then I just need to know which one of these is larger. And 5/3 is larger than 2/3, so my x is going to stay in the bottom because the bottom was bigger, and this is going to be its power, so to the 1st power. Always have to have a placeholder if I end up on the bottom with nothing on the top. So you can put the little 1 power there or not, but this is going to be 1 over x. Okay, so part C, we got those parentheses, so we're going to distribute to the one and only exponent in there because there's only one number in there, and when we distribute, we multiply, so we're going to be x to the 3 over 2 times 1 over 2 power, and I can't cross cancel or anything, so this is just going to change into 3 over 4 because we multiply straight. Okay, here we're going to distribute as well, but this time I think it's going to work out a little nicer, so we're going to be 5 over 6 times negative 3 over 1, and I can cross cancel there because 3 goes into itself once and into 6 twice. So this is going to be x to the negative 5 over 2 power. Now that feels like we're done. However, part of the rules is you can't have negative exponents. So whenever I do, I have to move where that number is. And right now that number is in the numerator over 1 because I'm always over 1. And so this whole thing is going to move to the bottom so that it can be positive. So 1 over x to the 5/2 power. Okay, for part E, like I can't divide in here, make it any smaller, so the only thing I can do is the parentheses and like distribute that exponent to all the exponents in there, and 64 and x both have an exponent, so 64 to the 2/3 power over x to the 2/3 power. Now x, I definitely don't know what that is to the 2/3 power, but I really don't know what the 2/3 power even means yet, so we're just going to have to leave it like that. We'll get there eventually though. And then last but not least, we got those parentheses, so we're going to distribute, and 8 has an exponent and so does x. They're both exponents of 1, so they both get that 1/3. and 1 times 1/3 is a third. So we're going to be 8 to the 1/3 and x to the 1/3. And we can't go any further than that because I don't know what the 1/3 power means. Okay, so your homework is just about simplifying exponents. Your exponents might have fractions in them, so you need to remember how to add, subtract, multiply fractions. So hopefully that's helpful. Good luck, guys.